The slide is visible?
Yes, sir.
Yes, sir, visible, sir.
My voice is clear.
Yes, sir.
Yes, sir, clear, sir, very clear.
Yes, thank you very much. Thank you, organizers, for inviting me for this FDP program. So, myself, Poovazhagan from SSN College of Engineering. So, in the last 6 days, you might have learned something about generative.
போட்டு வச்சிருக்காங்க அதான் சரி என்ன அப்படி இல்ல கஸ்டமர் என்ன உள்ள போயிட்டு வந்திருப்பாங்க வண்டியை நைட்டா கூட வந்து
Dear friends, please mute yourself.
I record the participant. Please mute your mic.
Let me mute all. Give me a minute. Sir, Poovazhagan sir, please unmute and speak, sir. I have given unmute for everyone. Now you can speak, sir.
Yes, sir. Thank you very much. So my talk will be mainly focusing on the lightweight structural material, because in the last 6 days you might have learned more about the generative design and additive manufacturing concept. So my focus will be mainly on the lightweight structural material and what are all the material that is more suitable in the lightweight category that can be used in the additive manufacturing technology. So whenever we are talking about lightweight material, mostly the density will be around less than 5 grams per centimeter cube. If it is more than 5 grams, mostly we are not going to call it as lightweight materials. Also, these lightweight materials widely accepted in the structural applications like the automobile body panel or the frames or bicycle frame, two-wheeler frame, or even the constructive materials like RCC structure, reinforced cement concrete. All this we can call it as the structural material. But out of the structural material, if the materials are having the density lesser than 5 grams per centimeter cube, that we can call it as light job. Whenever we are using this steel, if we are using aluminum, one-third of the weight, whenever we are going, that is leading consumption. Whenever the fuel consumption is naturally, we are moving towards the sustainable lifestyle. That is where the world is moving nowadays, the sustainability. So whenever we want to achieve the sustainable concept, one of the way is to reduce the fuel consumption so that we can able to reduce the carbon emission. If you want to reduce the fuel consumption, we need to go with the lightweight material. So out of the available lightweight structural material, aluminum is widely accepted. Magnesium also nowadays we are trying to use it. Also titanium, we are using it most of the application in the aircraft industry. Even though steel is very widely accepted structural material, it is not coming under the lightweight category as the density is around 7.8 grams per centimeter cube. So with this small introduction, now I am moving into the topic. So this is about the SSN, one of the very good green campus in India. So we are the only self-financing affiliated college in the NIRF ranking less than 50. So this is about my credentials. So as of now, I have guided 7 scholars and 6 scholars are currently pursuing PhD. So at the end of this lecture, we will try to understand what are all the selection criteria we are going to use to select the lightweight material for additive manufacturing processing. So my focus will be mainly on the lightweight structural material, what are all the selection criteria, and what are all the widely acceptable additive manufacturing technology that can be used for the lightweight structural material manufacturing by layer. This is the content in which I am going to present. The first one is the introduction of lightweight structural material. What are we are doing material and what are all the methods available for selecting the lightweight structural material, and what is the role of additive manufacturing in the fabrication of lightweight structural material, and what are all the most important additive manufacturing technology we can use it for manufacturing the lightweight this station, or so that we can able which particular additive manufacturing technology shall be used to manufacture any one particular lightweight structural material. Also, at the end, we will have some quiz session so that we can have these materials are widely used in the structure. The well-known structural application is, for example, the commercial buildings or residential building or educational building, where we are using RCC, reinforced cement concrete, as a structural material. So widely we are using in the application of beams, column, and also in the automobile chassis we are using, for example, aluminum panels, also bicycle frame. All these are some of the example of structural material. So I am not in this case talking about are some of the materials that can be used in the structural application.
Sorry for interruption, sir. Your
Yes, sir.
voice is not stable, sir. Here and there is a mute and unmute, sir. I think maybe some internet connection, connectivity, or headphone problem, sir. It's not continuous.
Yes, sir. Sir, my voice is audible now?
Now audible, sir. Now audible, sir. It's not like a continuous flow. There and there, here and there was some break.
Okay, sir. Okay. Now it is okay, sir?
Yes, sir. Yes, sir. Yes, sir.
Okay. So if you are talking about the structural material, actually that is giving the shape to any machine element or even the buildings or roadways or any commercial application. You can find n number of structures. In all the structures, we are using the structural material. So widely acceptable structural material is steel. If you are taking 10 widely used materials category, out of 10, 5 are steel material or steel based. Even though steel is heavy, the density is around 7.8 grams per centimeter cube, but the strength, ductility, or more importantly, the toughness of the steel is very good. Whenever any material which is having very good toughness, that indicates that material is having very good strength. At the same time, it is having adequate amount of ductility. Whenever the any material is having good amount of ductility and good amount of strength, that is the material we required in most of the engineering applications. So that particular property is known as toughness. Any material which is having high strength and good amount of ductility, that material naturally going to have good amount of toughness. Whenever we are going to select any material for engineering application, the most significant property what we are going to look for is the toughness, because whenever we are having material, we are having both strength as well as ductility. So these structural material tend to have good amount of strength, good amount of stiffness. Whenever we are talking about the strength, that means it is used to carry huge amount of load. Whenever we are talking about the stiffness, that is high Young's modulus, that material naturally tends to have good amount of resistance against the deformation. Whenever any material is having good toughness, naturally it is going to have both strength as well as ductile property. So whenever we are selecting the material structural application, all these properties are more relevant. So ultimate aim of any structural material is to withstand the applied load. The applied load may be in the form of send, that is pulling, it may be compression, pushing type of load, or bending, yeah, deformation, or shear type of load. So the ultimate aim of any structural material is to have the tensile component shear and bending type of load. Whenever we are going to look at as light, that type of material not naturally will be having the density lesser than 5 grams per centimeter cube. So ultimately, the property what we are going to look in the structural specific strength and weakness. That is, for the given weight, much amount of material that is known as specific. For the given load, how material performs. That is known as specific strength. Similarly, for the given weight, that is known as good specific stiffness. So whenever any material is having high specific strength and high specific stiffness, that material are known as lightweight structural material. So these materials are generally used to withstand all type of loads, not only tensile, compressive, shear or bending. In real time, you can find any type of loading condition, suddenly applied impact load, any type of loading condition. So naturally, this lightweight structural material tends to have the resistance against. So whenever we are going to use the lightweight material in any of the application, ultimately we are going to reduce the weight of the system. Whenever the weight of the, for example, aircraft reduces, we are going to save huge amount of cost in the fuel consumption. Similarly, the energy savings also huge. Ultimately, we are moving towards the sustainability. That is the core principle nowadays all the developed countries are moving towards. So whenever we are talking about the sustainability, it is leading to the simple lifestyle of saving energy or saving the reducing the carbon footprint. So all the structural materials in the lightweight category are widely recommended in aerospace application, automotive, electronics, marine, even in the medical applications. But most of the applications are in the aerospace and automotive. In the aerospace, you can find titanium, aluminum, magnesium. Nowadays, n number of composite materials are used in the lightweight category. Similarly, in the automobile also, we are finding n number of lightweight structural material. So this particular slide will give the idea about the widely acceptable structural material. As already mentioned, steel is widely used structural material, but only problem with the steel is the density. It is huge, 8 grams, around 8 grams per centimeter cube. But you can find the toughness, it is very good. Out of the available material in this category, steel is having highest possible toughness. Then coming to the aluminum alloy, it is alternative to steel in most of the aircraft and automobile industry. The density is around 3 grams per centimeter cube. So almost 1/3 of the weight we are going to save whenever we are going to use aluminum as a replacement material for steel. But you can find the fracture toughness value. The maximum is around 35. So it is also around 1/4 of the steel only. So we need to compromise. We need to also consider the cost factor. If we are taking the steel, the cost is somehow less. But whenever we are considering aluminum or titanium or magnesium alloy, the cost is huge. But correspondingly, we are going to save the weight. Whenever we are going to save the weight, naturally, the fuel consumption will be less. Whenever the fuel consumption is less, the carbon footprint also very less. At the end, we are moving towards the sustainability. That is a core principle of lightweight material. So these four materials are widely acceptable lightweight structural material in the metal category. So I am talking about the metals or alloys. Apart from this four, RCC, that is reinforced cement concrete, that is also widely used in the structural application, but the density will differ depending on the type of concrete.
I'm not using mobile, laptop only.
Sir, please mute yourself.
When it will start?
Hello. Yes, sir. Is it audible now?
Yes, sir. Yes, sir. Please proceed, sir.
Yes, sir. So first four are the widely acceptable structural material. The bottom, the highlighted in red color, are well-known material, but that is we cannot use it in the structural application. If you are taking glass, it is widely used, but that cannot be used in the structural application as it is very, very brittle. If you are taking paper or wood pulp, that is also widely used. Even though the density is very low, you cannot use it in the structural application as it is very, very soft. Similarly, the rubber, lead is very heavy, around 11 grams per centimeter cube. If you are taking gold, gold is having very good ductile property, but it is huge. Density is huge, around 20 grams per centimeter cube. Also, it is extremely expensive. So you cannot use gold for the structural application. Even the graphite, that is known as solid lubricant, that is also we cannot use it in the structural application because that is also naturally brittle. So for the structural application, we need to have the good strength, good fracture toughness. That means we need to have both strength and ductility. Then only that type of material we can use it in the structural application. So out of this available structural material, aluminum are widely used. Next to aluminum, titanium is used. Magnesium nowadays finding lot of application, but the problem with the magnesium is it is poor in ductile property. Also, the corrosion resistance is very, very poor. Even in the natural atmosphere, magnesium tends to corrode at a faster pace when compared to titanium or aluminum. Even though the density is very less, for some specific application, you cannot recommend magnesium as it is having poor fracture toughness, at the same time very, very, very poor corrosion resistant properties. So if you are considering the lightweight structural, then aluminum alloys and titanium alloys are widely acceptable material in the metal or alloy category. If you are considering composite material, then the carbon fiber reinforced composite or glass fiber reinforced composite are widely acceptable lightweight structural material. So I am taking one case study. For example, if you are considering the aircraft application, current trend, as per current trend, almost 50% of the weight of the aircraft in the Boeing 787 is composite material. You just find 50% of the weight. But if you are taking the history, some 30 years back, mostly steel was used in the Boeing 787. Now almost 50% of the weight of the aircraft is made up of composite material, mostly some of the fiber reinforced composite. Next to composite, you can find titanium, aluminum around 20%, and titanium and its alloy around 15%. Then steel. Still we are using steel 10%. Other material like magnesium around 5%. But the major issue whenever we are going to steel is, for example, each 1 weight percentage of the reduction in aircraft weight leading to almost 0.75% decrease in fuel consumption. This leads to, for example, you are reducing the weight of the aircraft to 14.5 kg in a net, that leads to around US dollar 1.2 million in the annual fuel savings. You can find the benefit of using lightweight material in the structural application. Even by reducing 15 kg in the aircraft, we can save around 1.2 million US dollar money annually. Apart from this, whenever the fuel we are going to save, the carbon emission or carbon footprint also we are going to reduce. Whenever the carbon footprint or carbon emission is reduced, that is a concept where the world is moving towards, that is sustainability. So if you want to have the sustainability, one of the way is to move towards the lightweight material. So this FDP is more relative to the lightweight structural material that can be used in the additive manufacturing applications. So these are all the some of the examples of structural material in which naturally we are using steel or cast iron. Whenever we are going to replace the steel or cast iron with lightweight material category like aluminum, you can save huge amount of weight. Naturally, you can save huge amount of cost cutting in the fuel consumption. So for example, the engine block, naturally we are using steel, but nowadays it has been replaced with aluminum alloy. Similarly, in the automobile wheel, this case study I will in depth I will discuss at the end of this lecture. For automobile wheel, we are also using steel, but it is heavier. The only advantage is it is cheaper when compared to aluminum or magnesium alloys. Similarly, the automobile body chassis, body panel, for all this previously we are using, or nowadays also we are using steel, but this steel nowadays is replaced with aluminum alloys. So several aluminum alloys nowadays available to replace the steel. The widely acceptable aluminum alloys are 6061, 6063, 5083, 5089, 5053, then 7075. So all these aluminum alloys are slowly replacing the steel in the automobile or aircraft industry. So ultimate aim is we are going to replace the denser material with the lightweight material. So coming to the selection criteria, whenever we are talking about the lightweight structural material, we need to consider all these important properties. If we are considering the mechanical properties, the foremost is toughness. Remember this term, toughness is playing the major role in selecting any material for any type of engineering application. Whenever I am calling the material is having good toughness, that indicates that material is having very good strength, at the same time that is having good amount of ductility. That is, if you are taking the stress strain diagram, it is having very good x-axis, that is ductility, also very good y-axis, that is strength. So the material which is having good strength and ductility is naturally going to have very good toughness property. Then stiffness, that is resistance against deformation. Any material which is having good amount of elongation, good amount of Young's modulus, that material will be having good amount of stiffness. Actually, stiffness is measured by measuring the yield, by measuring the by measuring the Young's modulus of the material. Then fatigue strength. Fatigue strength is the repeated type of loading. Whenever any material is subjected to repeated type of loading, that material will be having fatigue type of loading. So all these mechanical properties are very much important whenever you are selecting the lightweight material for structural application. Next, density should be very low. As per definition, it should be less than 5 grams per centimeter cube. Then only you can call it as lightweight material. So also it should be having very good corrosion resistance. Whenever we are talking about additive manufacturing, it should be having good additive manufacturing compatibility. That is, some of the additive manufacturing technology can be used to fabricate this type of lightweight structural material. So whenever we are talking about the sustainability, whatever the material we are choosing in the lightweight category, that should be recyclable. Whenever it is not recyclable, that is not sustainable material. That is the ultimate aim of sustainability. So what are all the methods available to select the lightweight material? So the well-known method is Ashby chart. So this you might have very much familiar. You are having ready-made chart. This particular chart will give the idea between the relation of two important properties like strength and density, that is weight, stiffness, that is Young's modulus and density, then stiffness and cost. By using Ashby chart, you can able to select the material with respect to I specific strength and I specific stiffness. Another well-known method is WPI method, weighted property index. For these two methods, I will give the demonstration how these two methods can be used to select the lightweight material for structural applications. Apart from these two well-known methods, nowadays ready-made softwares are available. We can directly use this online software to select the material for the lightweight application. Also, the well-known multi-criteria decision-making methods can also be used to select the material for lightweight structural application, like TOPSIS or fuzzy Promethy, even desirability analysis. All these methods can be used to select the particular material for structural application. Apart from this, we can also use now machine learning technology, also the expert judgment. Anyone who is having very good knowledge in the material selection, you can give the particular material for the selection of lightweight structural. So coming to the material selection category, the well-known chart is known as Ashby chart. Who invented this particular chart? So by using this chart, you can able to get the relation between the weight and density, or weight or fatigue strength, or weight or stiffness, anything. For example, this particular slide will give the idea between the density and tensile strength relation. For example, if you are going to very low density material, foams are available. But the problem with the foam is it is having very poor tensile strength. Then naturally available material, like some of the composites are naturally available. These materials also low in density, also very poor in tensile strength applications. Then alternative, these two materials are man-made materials. That man-made materials are composite material. You can find the various density of the composite material depending on the matrix, whether it is a polymer matrix or metal matrix or ceramic matrix. Depending on that, the density of the composite will change. Then ceramics also having very good low density, but the tensile strength of the ceramics is also not as much as comparable to the metal or alloy. Then coming to the metal or alloy, widely acceptable structural material in automobile, aircraft, marine and electronics industry. So most of the structural materials are metal or alloy based, like steel, aluminum alloys, titanium alloys and magnesium alloys. You can find the various density of steel, various density of metal or alloy. You can also find in between around 2 to some 5 grams per centimeter cube. You can find n number of metal and alloy category. So we need to choose depending on the application what is the tensile strength we required. Based on that, we can choose the composite or metal for the structural application. You cannot choose ceramic. Naturally, they are very hard, but the problem with the ceramic is they are very brittle. So the brittle material cannot be recommended for the structural applications. Then coming to the stiffness of the material, that is I Young's modulus. There also you can find most of the materials are belonging to metal or alloy, which is having I Young's modulus or I stiffness. So if you are going to choose the low stiffness material, then that cannot be used in the structural application. Even though the density is very low for polymer or natural material, it cannot be recommended for the structural application as its Young's modulus is very low. Whenever the Young's modulus is very low, it cannot withstand the deformation type of loading. So it can be easily it is deformable whenever the Young's modulus is very low. So we need to select most of the structural application. We need to select metal or alloys. Then another important property I mentioned, toughness. So all engineers, we need to based on the toughness point of view for the structural application. Whenever the toughness is very good, naturally the material will tends to have the high strength and high ductility. So this particular Ashby chart will give the idea what are all the material which is having high in the toughness and what are all the material is having low fracture toughness. So we need to select again based on the metal category or alloy category like magnesium, titanium, aluminum, steel. So all these materials are having very good toughness property when compared to composite or ceramics or polymers. So in most of the structural application, we are using metal or alloys because they are having very good strength, very good ductility. At the same time, they are having very good amount of toughness. Toughness is the most important property for the engineering application of any materials. So that is about the ASPE chart. So ASPE chart are directly available in the online. You can select what is the density of the material and what is the toughness you required, or what is the stiffness you required, or what is the strength you required. For example, if you want to have some 2.5 or 3 grams per centimeter cube, if you want to have around 100 megapascal strength, accordingly you have to select the material in this category. Mostly that will become magnesium or aluminum based alloys. So this ASPE chart will give the direct idea to select the material based on the weight or density relation with the various properties of the material like tensile strength or Young's modulus, that is stiffness. Method to select the material for lightweight application. WPA is very interesting method where if you are going to have n number of properties, for example, corrosion resistance, that is cost or fatigue strength or creep resistance or wear resistance, like that, if you are going to have n number of properties for the particular application, then you can use this WPA method where you need to list. For example, I have chosen the lightweight automobile wheels. Generally, steel is widely used in the automobile wheel, but nowadays we are talking about the alloy wheel. In the alloy wheel category, generally aluminum alloys are used. Still, if you want to reduce the weight, you can use the magnesium alloys. Naturally, whenever we are replacing the steel with aluminum, cost will increase. If you are replacing the aluminum with magnesium, again cost will increase. But we can save the weight. Whenever we are able to save the weight, we can able to save the fuel consumption cost. So we can able to move towards the sustainable related lifestyle. That is the ultimate aim of any lightweight material applications. Okay. So this WPA method is widely used whenever we are going to have multiple properties. So what property is most significant for that particular application, we need to assign the weight. For example, automobile wheel, which is the most significant property. For example, if it is tensile strength, you need to assign more weight to the tensile strength category for the automobile wheel material, then density, then corrosion resistance, then wear resistance, then cost. Like this, we need to give the weightage to the property that we are going to use it for the particular application. So for example, 5 is extremely significant, 3 is moderately important, and 1 is less important. All these are for the material and for the properties. For example, if you want to have automobile wheel, if you are choosing aluminum alloy, if you are choosing aluminum alloy, for example, for the automobile wheel, the most important property should be tensile strength or fatigue strength or corrosion resistance. So we need to assign weight, which is the weightage what we are going to do. That also we need to assign. Depending on this weightage, we need to give the rating. For example, for the automobile wheel, tensile strength is most important. So we are giving 5 to this weightage. Then density next is most important because we are going to consider I specific strength of the material. So density is also very important. That is, we need to have the material with less density. So for that, we are assigning the weight of 4. The corrosion resistant, naturally the wheel or automobile wheel, whenever it is moving over the road condition, it is subjected to huge amount of wear and tear due to estimating of any manufacturing industry is an economical action. We need to reduce the cost of manufacturing. So the cost for that we are giving the weightage of 1. We are considering only these 4 property. I have not taken here fighting. Fighting is also very much important for the automobile wheel, as the wheel is continuously rotating, it is subjected to repeated type of cyclic loading. So that property I have not considered here. We are considering only these 4 property. The total rating is around 30. So we need to get the importance for each property. For example, tensile strength 5 divided by 13, around 38.5 percentage. Density 4 divided by 13, around 30.8 percentage. If you are adding all this percentage, it will lead to 100. So by using this WPA method, we can find that tensile strength is the most important property for the automobile wheel applications. Next to tensile strength, density is playing the major role. So if you are considering the various methods available for selecting the lightweight structural application material, the ASHP chart is very simple, easily available, online source also available. You can directly consider the ASHP chart like density versus tensile strength, density versus stiffness, density versus fatigue strength, creep strength. From that you can choose the particular material. Then if you are coming to WPA method, depending on the weightages provided, what property is most significant, depending on that we need to select the material. So if you are considering the 2 particular methods, that can be easily available. Apart from that, nowadays if you don't have any provision of SP chart or WPA method, expert judgment can also be used to select the particular material for the given application. So in the lightweight material category, you can find n number of materials like aluminum alloy, the widely used lightweight material in the aircraft, even in the marine industry as well as automobile applications. The widely used aluminum alloys are 7075 in the aircraft, 6061 in the automobile industry. Still, if you want to reduce the weight, you can go with the magnesium alloys. It is around 7 grams per cube. In the sphere, it will be corroded easily as electrons are easily then even though titanium is density is around 4 as a lightweight material, mostly in the application. So from this metal or alloy, nowadays we are widely using carbon fiber reinforced, glass fiber reinforced, that is Kevlar. All these 3 polymer material with fiber. These type of polymer composite we are widely using in the automobile in some of the application of marine industry. So if you are considering all this material, most of the materials are magnesium type material. There is no steel here, even though steel is widely acceptable structural material, its density is huge, around 8 grams per centimeter cube. So it is not for. So this particular slide will give the idea for which material available for the given application. So the well-known material for the structural is around 1.7 to 1.8, but problem with the it is having poor fracture toughness and poor ductile. So when possible, we need to use aluminum alloy as its density is around 2.8 to 3.1 grams per centimeter cube. But for most of the aircraft application, we are also using titanium based material as its fracture toughness is very high when compared to magnesium or aluminum alloys. So these are all the materials widely acceptable in the lightweight structural application. So if you are taking the application point of view for the lightweight material, you can find n number of application of this material in the automobile industry, starting with automobile body chassis, body panel, engine component, fuel tanks, even automobile wheels. This case study we will discuss. So you can find n number of automobile components. They are using various types of lightweight material to reduce the weight, to reduce the fuel consumption, to move to reduce the carbon emission, to move towards the carbon footprint reduction. That is the ultimate aim of reaching the sustainability. Then aircraft is the most significant industry where always lightweight structural materials are recommended. So nowadays you can find n number of carbon fiber reinforced plastics we are using in the aircraft industry. Just now I mentioned almost 50% of the Boeing 787 nowadays they are using the some of the carbon fiber reinforced composite material. So widely acceptable structural material in the lightweight category in the aircraft industry nowadays is some of the fiber reinforced polymers or plastic material. Okay, with that small introduction of the lightweight structural material and selection criteria, now we are going to understand about the additive manufacturing concept. So you might be very familiar in the last six days different professors they might have handled the generative design and additive manufacturing concept. So I am not going to I am not going to teach in depth in the additive manufacturing technology, but what are all the additive manufacturing technology that can be used in the fabrication of lightweight structural material. Manufacturing or used in the lightweight structural application, you can find in the material savings because additive manufacturing or lead to less wastage when compared to conventional machining technology. So in the conventional machining, the material wastage is huge. Because of that only we are moving towards additive manufacturing. Also, as we are using some of the simplest form of CAD program, the complex geometry can be made by using additive manufacturing technology with the help of the lightweight structural materials. Also, the material weight we can able to reduce by using different lattice design or different topology design. By using that, we can able to reduce the weight of the material in the structural application whenever we are going to use additive manufacturing for fabricating the layer by layer addition of structural material. So the most important properties which we are going to consider for the structural application of additive manufacturing is density. That is the most important property. That is the I strength to weight ratio, that is known as specific strength. The material which is having I specific strength, that material naturally we are going to choose for the lightweight structural application. I specific strength indicates for the given weight which material performs better. For example, if you are taking 1 kg of steel, 1 kg of aluminum alloy 7075, 1 kg of carbon fiber reinforced plastic, 1 kg of magnesium alloy, for the given 1 kg weight, which material performs better? That is where the application of lightweight material is moving. So that particular property is known as I specific strength or I strength to weight ratio. Also, we need to have the good stiffness, that is I Young's modulus. I already mentioned we need to have the good toughness, that is the material should have high ductility and high tensile strength. Apart from this, for the structural application, we need to have the good corrosion resistance. Also, some of the structural component are subjected to repeated type of cyclic loading like automobile wheel. So that type of component should have high fatigue resistance. So whenever we are selecting the material for lightweight structural application, if that material we are going to fabricate by using additive manufacturing technology, we need to consider the first property is high specific strength, high specific stiffness, good amount of toughness, good corrosion resistance, and very good fatigue resistance. At the end, we need to move towards the sustainability. The material is having all this property. Also, we need to consider how this material can be processed by various additive manufacturing technology. So if you are considering all this, the well-known structural material that can be manufactured by using additive manufacturing or in the metal category, aluminum, the various aluminum alloys, different types of magnesium, titanium alloys. If you are considering composite, the carbon fiber reinforced, glass fiber reinforced, and Kevlar or aramid reinforced polymers are widely produced by using additive manufacturing technology. Also, the high performance polymer like beam, peak, and foams also nowadays used to fabricated by additive manufacturing technology. So whenever we are talking about the additive manufacturing, this is the simplest way to select the material by using additive manufacturing technology. The first step is we need to select what is the functional requirement. For example, if you are considering the automobile wheel, then naturally it should have the high load bearing capacity because it is continuously rotating or revolving over the road surface. The automobile wheels should have high load bearing capacity. Also, it should have the good corrosion resistant property. So the first step what we are going to do whenever we are going to manufacture any lightweight material by using additive manufacturing is you need to fix the properties that is required for the particular application. Whether strength is more important, stiffness is more important, toughness is more important, corrosion resistance is more important, wear and tear resistance is more important, fatigue or creep resistance is more important. That is known as functional requirement. So whenever we are going to select any material that is to be fabricated by additive manufacturing, first we need to consider the application point of view and what are all the important properties required. Second step, once you have decided what is the most important property depending on the functional requirement, then we need to categorize the material that is available to satisfy all the properties required that is defined in the first step. If you are considering the automobile wheel, for example, in the material category, these are all the materials available. So once you are able to identify the various material for the particular application that is defined in the first step, the third step is if you are choosing any of this material in the second step, what is the particular additive manufacturing technology we are going to use for the particular material you have chosen in the second step. For example, if you have chosen aluminum alloy, then what is the particular additive manufacturing technology that can be used to manufacture this aluminum alloy by using additive manufacturing layer by layer addition. So first step is select the application and select the properties. Second step is categorize the material or list the material available in the particular property category. After that, select the particular additive manufacturing technology method that can be used to manufacture this material layer by layer. Once you are able to complete all these three steps, then we need to consider what is the corrosion resistant requirement, what is the economical aspect, that is also most important, the cost factor. At the end, the business can survive if you are able to earn more profit. If you are going to have the more profit, then you have to reduce the production cost. If you want to reduce the production cost, you need to reduce the material cost, that is raw material cost. So the economical factor also playing the major role whenever we are selecting additive manufacturing for manufacturing the lightweight structural materials. Then the topology and lattice design we need to consider. So for example, in the topology optimization, you can find two components in this slide. So in this two, naturally we are going to choose the right one because it is using lesser material when compared to the left one. So that is the topology optimization. So we need to use minimum material, but that material or that particular component manufactured by using minimum material should satisfy the required purpose. That is known as topology optimization. So we need to use minimum material to manufacture the component. That component has to fulfill the requirement of withstanding the required load. Then lattice structure is known as how the 3D printed or additive manufactured network is arranged. So all these are some of the images of lattice structure that can be produced by additive manufacturing or 3D printing. So ultimately, whenever you are going to use additive manufacturing for interface, we need to consider the application point of view. For that application, what are all the properties required? For that properties, what are all the materials available? For that material, what are all the additive manufacturing methods available? So out of this additive manufacturing method, which particular method is more suitable for the particular lightweight material? After that, we are going to consider the environmental aspect, that is corrosion resistance, economical aspect, that is low production cost. So after this, we are going to consider to save the weight, the topology and lattice structure optimization. Finally, we are going to approve the particular material that is available in the second step and the particular additive manufacturing method that is chosen in the third step. So for example, if you are considering automobile wheel, what are all the properties required? We need to list. What are all the materials available? We need to list. What are all the methods that can be used to manufacture the material chosen in the second step that we need to finalize. So these are all the simplest way to select the particular additive manufacturing method to manufacture the lightweight structural material. So depending on that particular discussion, you can have the various lightweight structural material that can be used in the additive manufacturing technology. For example, the aluminum alloys, the widely used aluminum alloy is aluminum silicon alloy. That alloy we can manufacture by using selective laser melting, direct metal laser sintering, binder jetting. For example, if you are moving towards titanium alloy, you can use electron beam melting, selective laser melting, and DMLS. If you are using magnesium alloys, again you can use SLM technique. So for all this metal-based additive manufacturing in the lightweight structural category, you can use this additive manufacturing method for the better topology optimization, better lattice structure formation. If you are using the polymers for the lightweight matter, again these are all the additive manufacturing methods you can use. The widely used method is FDM if it is polymer. Also we can use selective laser sintering or multi-jet fusion for the nylon fabrication by using additive manufacturing technology. If you are going with high performance polymer like PEEK, polyether ether ketone, then FDM and SLS is widely recommended. If you are moving towards natural material that is elastomer, you can use again FDM, SLS. So these particular slide will give the idea how to choose the additive manufacturing method for the particular lightweight material that is based on polymeric matrix component. Then nowadays we are widely talking about composite because of the lightweight category. So in the composite material, there will be a matrix, there will be a reinforcement. That reinforcement we are going to embed into composite material by using additive manufacturing. Composite manufacturing, additive manufacturing technology. For example, continuous fiber FDM or fiber filament, that is FDM technology. If you want to manufacture Kevlar reinforced polymeric material. So these particular 3 slides will give the idea to select the particular additive manufacturing technology for manufacturing lightweight structural material, either by using metal or polymer or composite material. Remember, the ceramic material cannot be used in the structural application as it is very, very brittle. Even some of the composite materials are brittle. So the one interesting case study, this will be the last point in my lecture. So in this case study, I have chosen the automobile wheel. For example, you can consider car wheel. For the automobile wheel, what are all the materials available and how we can use the Ashby chart, how we can use the WPI method to select the particular material depending on properties required for the automobile wheel application. So ultimate aim of this case study is we need to manufacture the lightweight alloy wheels by using additive manufacturing technology. That is the core point of this lecture. So remember, in the lightweight category, if it is metal or alloy base, we can use magnesium, we can use aluminum alloys, we can use titanium alloys. You cannot use steel, you cannot use gold, you cannot use copper base alloys as their density is more than 8 grams per centimeter cube. So they are not belonging to the lightweight structural application materials. So naturally on the metal or alloy category, titanium base, aluminum base and magnesium base. Then if you are coming to polymeric base, then you can have the carbon fiber reinforced polymeric material. You cannot move towards the ceramic base material as it is very brittle, that cannot be used in the automobile wheel application as it can be easily breaking during the real-time applications. So first aim is to reduce the weight. That is the concept of lightweight structural application. To improve the fuel economy, whenever the fuel consumption is less, then cost cutting we are going to have. Apart from cost cutting, carbon emission will be less. So we are going to have the less carbon footprint, that is CO emission. Whenever CO emission is less, carbon footprint is less, then we are going to satisfy various norms. Now it is available for the automobile fuel consumption or automobile emission. Then we are moving towards the sustainable concept. Choose the component for the particular application. We need to ensure the mechanical performance of the material is satisfied. That means you cannot directly, for example, choose magnesium alloy for the automobile wheel application. If the magnesium alloy is not having required strength, required toughness, required corrosion resistant, you cannot blindly choose magnesium alloy even though it is having very good very low density. So whenever it is having low density, the fuel consumption is as magnesium is poor in related. So we need to deal based on the so based on that, we need to consider the following points for the automobile wheel application. The first, we are moving
Sorry for interruption, sir. We couldn't hear your voice, sir.
oh, just now or previously also?
Just for
Now
2
only,
minutes.
sir.
Sir, there may be some
Now it is okay, sir.
Yes, sir. I think there is some network connectivity, sir. You may switch off your video and proceed, sir. Then you will get more powerful.
Now it. Okay, sir. Now it is audible.
Yes, sir. Yes, sir. Yes, sir.
Okay, sir. Okay. I think there is no network issue. The connection point may be very loose. Okay, sir. So whenever we are considering the automobile wheel application, ultimately these 4 points we are going to consider on the sustainability point of view. If we want to satisfy all these 4 points on the sustainability development goals related applications, then we need to choose lightweight material like light alloys, in that magnesium, aluminum, titanium. Composite, it may be carbon fiber reinforced or glass fiber reinforced. Then high strength steel, this cannot be recommended as it is having huge weight. Then some of the advanced material, if you are going to choose, the cost will be the issue. So to compromise all this, we need to select any two material from lightweight alloys or composite material. So coming to the application point of view, that is automobile wheel. We all know there are two types of wheel in the automobile. One is the conventional steel base, another one is alloy wheel. So naturally, whenever the alloy wheel we are going to choose, cost will be higher. So if you are considering only cost factor, we need to select steel. But if you are considering the aesthetic look, fuel savings, then we need to select alloy base wheel. In the alloy base, mostly we are using aluminum alloys, because if you are using magnesium based alloy, the corrosion resistance will be very, very poor, as automobile wheels always generally having application in the open atmosphere. So for the automobile wheels, for the functional, that is property requirement, we need to have high strength in the dynamic and static loading condition. Another important property is we need to have the high fatigue resistance, that is repeated cyclic loading condition. Whenever the automobile wheel is rotating or revolving on the road, it is subjected to repeated type of cyclic loading. So we need to have the high fatigue strength for that particular material. Also for the lightweight category, we need to have the low density. Also for the automobile wheels, we need to have the very, very good corrosion resistant property. If you are considering all this point, then we are talking about the additive manufacturing. Then whatever the material we are selecting, that should be compatible with the additive manufacturing. So we need to consider strength, fatigue resistance, weight, corrosion resistance, and thermal stability. If you are considering all this point, then that particular material should be compatible with the additive manufacturing technology that can be used to process that particular material. If you are satisfying all this, at the end we are having the economical aspect. That is where the business is running. If the cost is huge, again that particular method or material we cannot choose. On the sustainability front, we need to select the material which can be recyclable. So
நான்
mostly,
அனுப்புறது வந்து அது டவுன்லோட் பண்ண மாட்டேன்ல, உங்களுக்கு
sir,
கடைசியா
please,
அனுப்பிச்சு தானே அனுப்பிச்சிருப்பேன்.
sir, please mute.
சார் இது வந்து பர்பஸாக பண்ண போறோம் சொல்றேன்.
Okay. Dear participant, please mute yourself. So once you are selecting the material for the application point of view, then I already explained two important concepts for the material selection. One is Ashby chart, another one is weighted property index, WPA method. So if you are considering the Ashby chart, the charts are ready-madely available. You can choose any of the particular material by referring the different chart. For example, density versus strength, fatigue strength versus density, stiffness versus density. By considering these three charts, you can list the material available for the automobile wheel application. So whenever we are considering the three, that is the properties in the first step, you can find these material by using the Ashby chart. For example, aluminum alloy. The widely used aluminum alloy for the automobile wheel is aluminum silicon alloy. Another alloy is scandium reinforced aluminum alloy, then titanium alloy, magnesium alloy, even carbon fiber reinforced plastic can be used for the automobile wheel application. Even aluminum metal matrix composite are tried in the automobile wheel application. So by considering the functional requirement in the first step, by using the Ashby chart, the potential material for the automobile wheel applications are aluminum alloy, titanium alloy, magnesium alloy, carbon fiber reinforced plastics, and metal matrix composite based on aluminum silicon carbide reinforcement. So from this available potential material, we need to again categorize which particular material we are going to choose for the automobile wheel application that can be manufactured by using additive manufacturing. If we are considering that point also, we are going to select only these two material, aluminum silicon alloy and scandium reinforced aluminum alloy. If you are considering these two alloys are very good in all these properties. Also, they are compatible with different types of additive manufacturing technology. Also, they are having very good strength to weight ratio, that is I specific strength. They are having very good fatigue resistance. Another important property required for additive manufacturing is printing quality. So these two materials specifically, aluminum silicon magnesium alloy, scandium aluminum alloy, are easily additively manufactured. So by considering the properties, by using the Ashby chart, we have listed these are all the material can be used or recommended for automobile wheel application. From this, by considering the various points, these two aluminum alloys are most suitable for manufacturing structural lightweight automobile wheel by using various types of additive manufacturing technology. Then once you have selected these two aluminum alloy, aluminum silicon alloy, the scandium aluminum alloy, we need to select particular additive manufacturing method. For aluminum alloy, the widely used additive manufacturing method is DMLS or SLM. These two methods are widely used for various aluminum alloys. For titanium alloys, EBM method is chosen. Wire arc additive manufacturing cannot be chosen for this particular application as it is having poor surface finishing quality. So DMLS and SLM are widely used to fabricate lightweight structural aluminum alloys based on aluminum silicon magnesium or scandium based aluminum alloys. So these two aluminum alloys can be easily manufactured by using these two additive manufacturing technology. So from these two aluminum alloy, again we need to select any one that can be more suitable for the automobile wheel applications. If you are considering these two aluminum alloys, you can consider the tick mark. Aluminum silicon alloy is having major tick mark whenever we are considering the particular additive manufacturing technology. Even though scandium aluminum alloy is having very good property, on a whole, the all-round performance, if you want to get, you need to select aluminum silicon magnesium alloy. So these two aluminum alloys can be manufactured by using DMLS and SLM additive manufacturing technology. This is how we need to select the material for the particular application. Starting with the functional requirement, list the material available by using Ashby chart, and considering the additive manufacturing compatibility, select the suitable or most suitable material for the particular application. Then coming to the WPA method, this is most important step. For example, for the automobile wheel application, you can have aluminum silicon alloy, you can have scandium aluminum alloy, you can also have titanium base alloys. Out of these three material, we need to select any one that can be used to manufactured by using additive manufacturing technology. For example, we need to assign weight. The introduction I have already given. If we are considering the automobile wheel application, most important property is strength. For that, we are assigning 25% weight. As it is subjected to repeated type of loading, we are assigning 20% of weight to fatigue resistance. Like this, we are assigning weight for all the factors. Even additive manufacturing printability characteristics also very important. If you are adding all this weight percentage, that is leading to 100. Now we have chosen three material, or now we are being provided with three material. Aluminum silicon alloy. For that we need to assign weight. For strength, this is 7. But scandium aluminum alloy is having very good strength to weight ratio. But on your overall, if you are considering assigning weight to all these three material and adding, you can consider aluminum silicon alloy, for example, 7 multiplied by 10, 70. So 70, 60, 80, 90, 80, 90. If you are adding all this, it gives 770. Similarly, scandium aluminum alloy 765. Titanium aluminum alloy, it gives 685. So you can easily understand out of these three available material for the automobile wheel application, by using WPA method, aluminum silicon alloy is having maximum percentage of marks, 770 score. So even though titanium alloy is having 685, at the end, if we are considering the cost factor, then this is not correct. The cost factor, titanium is not less, aluminum is actually less. This needs to be changed. So if you are considering all round performance, also the printability characteristics with respect to additive manufacturing, the aluminum silicon alloy via selective laser melting is the most suitable material, and most suitable method is additive manufacturing for this particular aluminum alloy applications. So this is misleading. This is not correct, this particular though. So this one you leave it. If you are considering aluminum silicon alloy and scandium aluminum alloy, aluminum silicon alloy is having more score. So that particular material we need to select for the automobile wheel application, and also by using selective laser melting category additive manufacturing technology for this particular aluminum alloy. So on a whole, this particular aluminum alloy is having 30% weight reduction when compared to steel. Also, it is having very good fatigue resistance. Whenever we are using SLM additive manufacturing, the surface finish also very good after doing some forced additive manufacturing machining methods. The leading time is also very less whenever we are using additive manufacturing for manufacturing aluminum silicon alloy for automobile wheel application. Another important advantage is the design. We can have tailor-made design for additive manufacturing. So with this, the session is over. On a whole, the aluminum silicon magnesium alloy is the best available alternative for the automobile wheel application on lightweight structural category. This aluminum alloy can be easily manufactured by using SLM method. Whenever we are manufacturing this particular alloy by using SLM method, we can have lightweight, we can have easily manufacturing capability by using additive manufacturing. The reliability on the mechanical application is also good. The cost effectiveness is also very good for this particular aluminum alloy. So on a whole, if we are considering these two aluminum alloy for the automobile wheel application, even though scandium aluminum alloy is having very good strength, it cannot be directly chosen because it is not economically feasible to choose scandium base aluminum alloy over aluminum silicon alloy. On the cost factor, we need to select aluminum alloy because we need bulk volume for the automobile wheel applications. Also, the best available additive manufacturing technology is SLM method for manufacturing aluminum silicon alloy for automobile wheel application. So with this, my presentation is over. So we will now, the participant can answer the quiz questions. Very simple quiz question I have given based on my presentation. After that, we will have the discussion. The first question is, which of the particular property is most required for the lightweight structural application? Can anyone, you can just unmute yourself and you can answer these questions. What is the most important property we are going to consider for the lightweight structural application?
So
Can anyone?
density.
Density, very good. Density, because we are talking about the lightweight material. So I strength to weight ratio or I stiffness to weight ratio is playing the major role. Okay. So second question, for the application of aerospace frames, what is the property we are going to mainly choose for the lightweight as well as load carrying capability?
Strength to weight ratio, sir.
Very good. I strength to weight ratio. That is where the topic is mainly focused. Then another interesting question. You have been provided with two important material for the automobile wheel application. The material A is having some density and tensile strength. Material B is having some density and tensile strength. Now, what is the procedure we can adopt to select any one of this material for the automobile wheel application? So how to select the material for the application point of view for automobile wheel? Again, the same property we are going to consider. Strength to weight ratio. You consider the strength, you divide by density. So which is giving good strength to weight.
Material B. Select.
So depending on the calculation, you can select. Okay. Then coming to the fourth question, which of the software tools is directly used for selecting the materials for the application point of view? What is the software we are using for selecting the material? Software. So in one of my slide, the answer is available. If you are considering the software, AutoCAD is not material selection software. ANSYS is also not material selection. SolidWorks also not used in material selection. So answer is B. Then coming to the next question. In WPA method, all properties are given equal importance. True or false? Anyone please answer? In WPA method, all properties are given equal importance.
False, sir.
It is false because
False, sir.
it is false, correct. Because property matters. That is what the method is explaining. Weighted property. Which property is most significant? For that we are going to assign more weightage. Okay. Then the sixth question, the WPA method, the weight assigned to the property represents it is absolute or relative or depending on the manufacturing cost or density, which we are going to select. So it is relative importance. So whenever we are going to consider multiple property B for the particular application, it is of relative importance. There is no absolute importance for any property for any application. It is of more relative importance to the properties. Then seventh question, which of the following metal is most widely used for the lightweight aerospace application? What is the answer? Lightweight air.
Titanium.
Yes, titanium, because all another three are more than 8 grams per centimeter cube. So that is not the lightweight material. The next one, which lightweight metal is particularly valid for marine application because of the natural corrosion resistant. This I have not, I think, covered in the slide. Out of these 4, which is having very good seawater corrosion resistant or widely used marine material?
Aluminium.
Yes, sir. So aluminum alloy 5083, it is marine grade aluminum alloy. So 5083 is widely used marine grade aluminum alloy. So this is the last slide. So in additive manufacturing of automobile wheel, which material property is most critical for high cyclic load resistant condition?
Fatigue strength.
Fatigue, that is the property required for repeated type of cyclic loading. Then the last question, by using which particular Ashby chart you can going to select for lightweight additive manufacturing under cyclic loading condition?
Option A is
Yes.
fatigue strength
So all are
resist
very good. All are very simple question only. So with this, my presentation is over. So you can contact me to this mail ID, to this mobile number. So I am having here casting facility for manufacturing aluminum composite as well as nano composite. If anybody want to do aluminum nano composite, you can always contact me. Now it is open to the participant. If you are having any doubt, now you can ask. It is almost around 3:30 now. Any doubt? Now you can ask. Anyone, can you give the feedback? Anything I want to improve? Anything you can tell, because we are in online mode. I am not able to see your faces.
The question is posted in the chat box, sir. Let me read out, sir.
Yes, sir. Yes, sir.
Sir, which material is best for lightweight structure in additive manufacturing?
Yes, that is purely depending on the application point of view. I have given one demonstration for automobile wheel. For that automobile wheel, the aluminum silicon alloy is best chosen. Like that, first we need to consider the application point of view. For that, we need to consider the properties. We need to use WPA method to arrange the properties according to the importance. After that only we can claim this particular lightweight material can be used this particular additive manufacturing technology. So everything is purely depending on the application point of view. Yes, sir. Any other questions?
There is one more question, sir. What role do composite materials and alloys play in achieving lightweight designs?
Yes, very good. So if you are considering the composite material, voice call from MIT. So if you are considering the composite material, mostly we are going to use composite material to reduce weight. For example, if you are using aluminum silicon carbide, we are using silicon carbide as the reinforcement. So you cannot use, for example, copper based composite or steel based composite for most of the structural application. If you are considering the composite material on the metal base, aluminum or magnesium or titanium based composite material can be used for the lightweight application, provided if you are able to maintain the toughness and ductility of the material for the application. Then the well-known composite material in the lightweight structural category are carbon fiber reinforced, glass fiber reinforced, polymeric material. Almost I have shown in one of the slide, the Boeing 787 uses 50% of the weight equivalent to composite material. So huge amount of weight savings you can do whenever we are able to use the composite material for the structural applications. So again, it is purely depending on the application point of view. Yes. Any other questions?
Sir, one more question from a participant who gave some fast answers for your quiz, sir. Mr. Stalin has asked a question. Does dynamic testing of additive manufacturing is available in SSN premises?
As of now, I think you might have you can contact Dr. A.K. Lakshmi Narayanan. He is having the additive manufacturing facility. I think yesterday he has delivered a lecture, correct?
Yes, sir. Yes, sir. Yes, sir.
You please contact him. He is having very good setup for friction stir welding as well as wire arc additive manufacturing. also for metal additive manufacturing. So you can contact him. Definitely the facility will be available. So that is funded by, I think, DST SERP. Around he has received 70 lakhs for developing that particular setup. Also he is having some ESAB welding funding. So around 2 crore funding he has received from the ESAB welding company. So he is having very good facility for additive manufacturing, friction stir welding, as well as wire arc additive manufacturing. You please contact him. He will give a better idea and answer for this. Yes, sir. Any other questions?
There is one more question, sir. What are the major challenges industries face in material qualification for additive manufacturing?
Yes, sir. The major challenges should be always in the topology optimization, how to use minimum material without affecting the performance for the particular application. I have shown in one of the slide the topology design. You can use more weight, you can use less weight, but we need to optimize it which particular topology design or lattice structure, that is 3D printing structure, will give the better idea for the particular application. This one, you can consider the topology design. In the right side, less usage of material. In the left side, more material is used. So naturally, we are going to use the left side design. So the topology optimization, again the lattice structure design, the 3D printing structure, these two is having wider range of optimization requirement. If you are able to optimize in this two category, you can save huge amount of material as well as cost, as well as you can reduce the weight drastically whenever the proper topology lattice design is followed in the additive manufacturing. Yes, sir.
Thank you, sir. I think there is no more questions. It was really an exemplary and explorative presentation. You made
Thank
the
you,
complex into step-by-step procedure with a lot of real-time examples and case studies, sir. Really, it shows your insightfulness and your confidence in your subject area. Thanks a lot for your wonderful time and your expertise sharing, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you very much. I am signing up now. If anybody want to do casting in the nano composite, you are always welcome to do at a session. Also, we are having
Thank you, sir.
Thank you, sir. Thank you, sir. Now I am closing the session.
Thank
Leaving
you,
the
sir.
session. Thank you.